Hello dear students, in the previous video we have discussed about the MCQ questions of electrochemistry. In this we will be discussing about the remaining questions. So here if we consider in a galvanic cell, the question number 21 is given as in a galvanic cell, chemical energy is converted into heat, electrical energy is converted into heat, chemical energy is converted into electrical energy, and electrical energy is converted into chemical energy. So we study about electrochemistry means it is interconvergence of chemical and electrical energy. When chemical energy is converted into electrical energy spontaneously, we call it as a galvanic cell, and electrical energy into chemical energy non-spontaneously, we call it as an electrolytic cell. So the correct option for this question is option C, where we say that chemical energy is converted into electrical energy. Next, question number 22. If a salt bridge is removed from the two half cells, the voltage, so here when you have two half cells, so this is one half cell having one electrode into it, one undergoing oxidation, that is anode. This is another half cell having an electrode into it, and both are connected here. Now when both are connected here, we say that the solutions are not connected. To connect the solutions, we add a salt bridge, and when you add a salt bridge, a potential is developed. If the salt bridge is removed, then the voltage will drop to 0 as the connection between the two solutions is removed. Hence the correct answer for question number 22 is drops to 0. Next, question number 23. An electrochemical cell consists of cadmium cell, lead accumulator, two half cells, none of these. So as represented above, two half cells connected by a salt bridge is an electrochemical cell. So here we can consider option C to be the correct answer. Next is question number 24. On electrolyzing a solution of dilute H2SO4 between platinum electrodes, the gas evolved at anode is. So there are two possible reactions at anode during the electrolysis of sulfuric acid. The two reactions we can consider it as 2H2O in liquid state forming O2 in gaseous state plus of 4EH plus in aqueous state plus 4 electrons, and its E0 value, that is EMF of a cell, is equal to plus of 1.23 volt. And similarly, the other possible reaction is sulfate ion undergoing oxidation to form peroxodisulfate ion plus of 2 electrons, and its E0 value is equal to plus of 1.96 volt. So experimentally it is seen that the equation 1 at anode occurs for dilute H2SO4 and equation 2 occurs for concentrated H2SO4. So equation 1 occurs for dilute H2SO4, equation 2 for concentrated H2SO4 at anode, and in the question they have asked is dilute H2SO4, hence the correct answer is oxygen gas is liberated, and it is option C. If we go with the next question, in an electrolysis of aqueous sodium chloride solution, which of the half cell reaction will occur at anode? So basically you should always know anode means which reaction occurs. It is oxidation reaction, and oxidation means loss of electron. So here if we consider, the first reaction is reduction. So first option cannot be the correct option because electrons are gained here. Second reaction, they have given H2O giving O2 H plus electron. So electrons are being removed, so it's an oxidation reaction. Third option, H plus plus electron. Again the electrons are on the reactant side, means it is gained. It's a reduction reaction. It's not oxidation. So this cannot occur at anode, this also cannot occur at anode. So we are left with this one, and the last one again if we see, we are having electron on the product side, that is chloride ion undergoing oxidation, that is loss of electron. So either of the one may occur at the anode. Now in this, which may occur at the anode, for that we'll consider the E naught value. So based on E naught value, you should know that the one which has a lower E naught value will easily undergo oxidation. So if we consider here 1.23 and 1.36, the lowest value is among the two 1.23. So we expect that this reaction should occur at anode. But it needs an over potential. Over potential means extra energy for the reaction to occur. Because of which, instead of this is a reaction that is preferred at anode, and the reaction that is taking place at anode in the electrolysis of aqueous sodium chloride is conversion of chloride to chlorine gas by the loss of electron, and hence the correct answer is option D. And why the option B, this reaction is not considered? It's due to the reason of over potential. Next, if we go with the next question, the electrochemical cell stops working after some time because electrode potentials of both the electrodes become zero, electrode potential of both the electrodes becomes equal, one of the electrode is eaten away, the cell reaction gets reversed. So the electrochemical cell stops after working some time because the potential of the both electrodes becomes equal. When the potential of both electrodes become equal, the electrochemical cell will stop working. So this was regarding question number 26. Next, question number 27. The metal which cannot liberate hydrogen from hydrochloric acid is. So if you recall the reactivity series, in electrochemical series we can see that. So we were having the reaction H plus of 2 electron forming H2 gas, and its electrode potential value E naught value was equal to 0.0 volt. So whatever metal comes above it, those cannot replace H plus ion, those are less reactive, and whatever come below it, they are more reactive. So if you remember the reactivity series at least of the 10th standard what you have studied, below hydrogen we have zinc metal, we have aluminium metal, as well as we have magnesium metal. And above hydrogen we have copper metal. That means zinc can displace H plus, aluminium can displace H plus, magnesium also can displace H plus, but copper cannot displace H plus from the aqueous solution in the form of H2 gas. Hence we say that the less reactive metal is copper, and it cannot liberate hydrogen from the hydrochloric acid. So the correct answer is option B, that is copper. Next, question number 28. The name of the equation showing relation between electrode potential E, standard electrode potential E naught, and concentration of ions in solution. So it is nothing but it's a Nernst equation. So we have seen the reaction, that is E of Mn plus bar M is equal to E naught of Mn plus bar M minus of 0.059 volt divided by N into log of 1 divided by Mn plus. So this is the equation which relates both electrode potential, standard electrode potential, as well as the concentration of ions in solution. So answer is Nernst equation. Question number 29. If the electrode potentials of A, B, C and D, so they have given E naught values, are these minus of 2, so A will represent it A, then B and C and D. So value of A is minus of 2.46, B is minus of 3.06, C is 0.0 and D is 1.24 volt. And they have asked here the maximum reactivity is of. So maximum reactivity here we consider it in terms of the tendency to undergo oxidation. So the most reactive metal is tendency to undergo oxidation means what? The one which has a more negative value or lower E naught value. So among this the lower E naught value is for B, and hence B is more reactive. So the correct option is B. So here what you have to remember, lower the E naught or electrode potential value, higher is the reactivity. Next, question number 30. If the E naught cell for a given reaction has a negative value, then which of the following gives the correct relationship for the values of delta G naught and K equilibrium? So already, as we have discussed, we know the relation, that is delta G is equal to minus NFE cell, or if it is delta G naught minus NF E naught cell. So if E naught cell is given a negative value, if I substitute here, I will get delta G naught to be a positive value. So if it is delta G naught to be a positive value, delta G becomes greater than 0. And if delta G is greater than 0, we'll consider we relate delta G naught by the equation as minus RT ln K. So if delta G is less than 0, K at equilibrium, if delta G is greater than 0, K at equilibrium will be less than 1, and hence the correct answer is option A, that is delta G greater than 0, because delta G will be positive. If delta G is positive, K will be obtained as what? Less than 1. So delta G is greater than 0 means K is less than 1, which indicates that the reaction is occurring non-spontaneously. It is more towards the reactant side and less towards the product side. We'll go with the next question, 31 question. Using the data given below, find out the strongest reducing agent. So one thing you have to remember here, based on E naught values. So if you consider the E naught value, if it is a greater E naught value, it undergoes easily a reduction reaction. If it is a lower E naught value, it will easily undergo oxidation reaction. And the one which easily undergoes reduction reaction, it is called as an oxidizing agent, and the one which easily undergoes oxidation reaction, it is called as an reducing agent. So if we consider the reactions here, so here E naught of chromium, manganese, chlorine and chromium are given, dichromate and chromium, So 1.33 volt, they have asked reducing agent. Reducing agent means it should easily undergo which reaction? Oxidation. And if it should easily undergo oxidation, it should have a lower E naught value, and lower E naught value among this is minus of 0.74. That means chromium will easily undergo oxidation to form chromium ion by the loss of 3 electrons. Hence chromium can act as the strongest reducing agent, and the correct answer is option B, Cr. Next, question number 32. A device that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy is known as, so already we have discussed, it is known as fuel cell, and one example also we have discussed about it, it was called as H2O2 fuel cell. Next, question number 33. In a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to generate heat, create potential difference between the two electrodes, produce high purity water, remove adsorbed oxygen from electrode surface. So whenever an electrochemical reaction is occurring, it is due to what we say here, potential difference between the two electrodes, and H2O2 fuel cell is an galvanic cell. Hence the correct answer is option B, creates potential difference due to the two electrodes. Next, if we go with question number 34, a standard hydrogen electrode has zero electrode potential because A, hydrogen is easiest to oxidize, B, electrode potential is assumed to be zero, C, hydrogen has only one electron, hydrogen is the lightest element. So here we are assuming that its potential is to be zero. Hence the correct answer is option B, the electrode potential is assumed to be zero. Next, question number 35. Rusting of iron is a or is an. So here the options given are reduction, oxidation, hydrolysis, precipitation. If the option would be given as redox, you could have considered redox to be the better answer over reduction and oxidation. Since they have just given rusting of iron is an example of what, the correct answer is oxidation. Why? Because when it rusts, so what was the reaction we have already discussed there, Fe2 plus of 2H2O plus of half results in the formation of Fe2O3, results in the formation of Fe2O3, which is an iron rust. So rust is formed by which reaction? Atmospheric oxidation reaction. Hence a suitable answer for this question would be oxidation. Overall rusting of iron is a process which involves both reduction as well as oxidation reaction, and we could have considered it as a redox reaction. But since this option is not given, the better answer would be oxidation. So with this we complete almost the multiple choice questions of electrochemistry. Remaining, we'll go with the next lesson in the next video, that is on chemical kinetics. Thank you for watching. Go through the questions.